Completed solving rational equations. A rational equation is an equation in which one or more of the terms is a fraction of one. When solving these rational equations, we utilize one of two methods that will eliminate the denominator of each of the terms. Method 1, where two fractional terms are equal to each other.
How it applies to real life. From anesthesia to economies, rational functions are used in multiple areas of study to help predict outcomes. Very well-known situations where rational equations can be used as a representation are medical dosage, cost of living, and economic production of goods. A rational function can be used to determine the concentration of a certain drug after a fixed amount of hours. For example, surgeries and operations can only begin after a concentration of a drug reaches a desired level. Therefore, this function is helpful for doctors to determine after how many hours they should start surgery based on the concentration level they prefer.
A rational equation is an equation in which one or more of the terms is fractional. When solving these rational equations, we utilize one of two methods that will eliminate the denominator of each of the terms. If the equation is in the form of a proportion, you can use product of the means equals product of the extremes, or cross multiplication to eliminate the denominator. Then solve the resulting equation and check. Number 1, identify the least common denominator. Step 2, multiply each side of the equation by the LCD. Simplify, then solve the resulting equation and check the answer. And these are just some graphs. The button.
So, for examples, for the first step, this is an example of solving one. To start, make sure you copy the problem down correctly. In this case, the problem is 2x over x plus 6 minus x squared minus x minus 10 over, I need to do this. So 2x over x plus 5 minus x squared minus x minus 10 over x squared plus 8x plus 15 equals 3 over x plus 3.
You need to find the LCD. This is short for least common denominator. To do this, you want to first factor all denominators if not already factored. And then you take each binomial from the bottom while excluding repeating ones. In this case, the LCD is going to be x plus 3 and x plus 5.
For the first step, you multiply the least common denominator that you just found in step 2. Make sure that you cancel out terms that match the terms in the denominator to make the problem much easier.
For the final step in solving a rational equation, you will want to simplify and solve the remaining terms. During this step, if you found the LCD correctly.
Okay, one real-world example is Myra takes 2 hours to plant 500 flower bulbs. Francis takes 3 hours to plant 450. Working together, how long should it take them to plant 1,500 bulbs?
If Myra does 500 bulbs for 2 hours, it equals 250 bulbs an hour, and Francis does 450 bulbs for 3 hours, it equals 150 bulbs per hour. Think about how many bulbs each person can plant in 1 hour. This is their planting rate.
Step 2, Myra and Francis together, 250 plus 150 bulbs an hour equals 400 bulbs an hour. Find their hourly rates to determine the rate they work together.
Use one of the work formulas to write a rational equation. We know R, the combined work rate, and we know W, which is the amount of work that must be done. What we don't know is how much time it will take to do the required work at the designated rate.
Okay, step 4 is solve the equation by multiplying both sides by the common denominator, then isolating.
It takes 3 hours, 45 minutes for Myra and Francis to plant 1,500 bulbs together.
Is that it?
That is one example.
Okay, another real-world example is Jamie, Priya, and Paul can paint a room together in 2 hours. If Priya does the job alone, she can paint the room in 5 hours. If Paul works alone, he can paint it in 6 hours. If Jamie works alone, how long will it take her to paint the room?
Determine the hourly rates for each person and for the whole group using the formula. Can you scroll down? R equals W over T.
Step 2, work is painting one room, so W equals 1. We don't know how long Jamie will take, so we need to keep the variables.
Write an equation shows that the sum of their individual rates equals the group rate. Think of it this way. Priya works for 1 hour and paints 1/5 of the room. Paul works for an hour and paints 1/6 of the room. Jamie works for an hour and paints 1/t of the room. Together they have painted half the room in 1 hour. Solve the rational equation.
First, find the least common denominator of the individual rates. It is 5 times 6 times t equals 30t. Oh, let me scroll down to it.
Sorry.
Then multiply each term on the left by a fractional form of 1 so that all rates have the same denominator and can be added. We could also have found the common denominator of the entire equation, which is also 30t, and multiply both sides.
Now multiply both sides of the equation by the common denominator, then simplify.
It would take Jamie 7.5 hours to paint the room by herself.
In a rational equation, the denominator cannot be 0. If there is a domain number that makes it 0, the equation would be undefined. For example, if a rational equation was 5 over x minus 5 equals 2, x could not be 5 because the problem would become undefined.
Okay, first you'll need to factor the quadratic so I can tell what factors have in my common denominator.
The factors of the quadratic equation are duplicates of the other denominators. This often happens for these problems. So the common denominator would be x minus 4 times x minus 2. And you'll need to remember at the end that x cannot be 2 or 4. I can convert everything to the common denominator and then solve the numerators.
Or you can multiply through on both sides by the common denominator and solve the resulting equation.
Either way, I get the same result, x equals 4 and x equals -1. Checking these solutions against the denominators of the original equation, I see that x equals 4 would cause division by 0, so I get rid of that solution.
And the answer is x equals -1.
All right. And I think that's it, right, guys? Awesome. There we go.